Hey guys, Gridius here. This is a video for proportional relationships, and you will notice our I can statement is I can identify a proportional relationship and the constant of proportionality. A lot of big words there, but as we continue to do this and work on this, it'll begin to make more sense between this slide and the next slide. So, big vocabulary word is proportional relationship. That is a relationship between two quantities in which the ratio is constant. Okay, so we'll talk about exactly what that means here on the next slide, so make sure you get that definition down though. So first thing I want to look at are the input-output tables. So we did these input-output tables before, okay? And what I want to do first, let's just complete this input-output table based on what we know, and then we're going to talk about whether or not it is a proportional relationship. So we've seen this one before. My rule for this one is it is being multiplied by 3 every single time. What's happening to my input? To get my output is my input is being multiplied by 3 every single time to get my output. So I'm taking my input, multiplying by 3, there comes my output. Input, multiplied by 3, here comes my output. Take 3, multiply by 3, here comes my output. So now I can finish the table by multiplying it by 3, and then you'd ask myself, what number times 3 equals 15? Well, that is 5. So I've completed my input-output table. I figured out what was happening every single time. Now, for this to be considered a proportional relationship, the rule has to be consistent throughout the whole entire table. So if I'm taking my input, 1, I'm multiplying it by 3 every single time. I'm taking my input, multiplying it by 3 every single time to get my output. That is a consistent rule. So therefore, this table represents a proportional relationship because the same thing is happening every single time. We will write our rule of this table the same way we wrote it before in this format, y equals ax. So what is happening to my input? I'm taking my input, I'm multiplying it by 3, so 3 times my input, and that is going to be equal to my output. That is how we write the rules and the equations of proportional relationship. Now, the only difference is we have a new term. Whatever that number a is, which happens to be this 3, this is the constant of proportionality. Okay, this piece right here is my constant of proportionality. So the constant of proportionality is the number that is being multiplied. The number that is being multiplied by my input. That's my constant of proportionality. That is what pretty much what the rule is. So let's look at something else here. So we've seen input-output tables. Now we're going to take a word problem. Take a situation here, and we're going to determine if the relationship is a proportional relationship. And then if it is, we're going to give that constant of proportionality. So here I have Lee, who takes 1 hour to drive 65 miles, 2 hours to drive 130 miles, and 3 hours to drive 195 miles. Well, I think we all know that you can change your speeds when you're driving in a car, so you don't have to drive the same speed the whole time, which means if her speed is changing every single hour, this would not be a proportional relationship. So we're going to take our unit of time and use that as our input. And then we're going to take the action, which is her driving a certain amount of miles, as our output, as our y. So here's my x, here's my y. So for hours, after 1 hour, Lee drives 65 miles. Oops. After 2 hours, Lee drives 130 miles, and after 3 hours, Lee drives 195 miles. So after 1 hour, Lee drives 65 miles. So that means what we're doing is we're taking our input, the amount of hours, and she's just multiplying it by 65 to get the amount of miles. So now what I need to do is I need to see, does this times 65 work every single time? Is that a consistent rule? Is she driving at the same speed every single hour? If so, then it is a proportional relationship. So let's just check to see what 65 times 2 is. Let's see if that holds true for this table. Because if 65 times 2 is 130, that's a good thing. And so we'll get 10, 130. That works. So now I need to check 65 times 3 real quick and see if that equals 195, just to make sure. You've got to check every single one. 195, it does work. So that means, yes, this is a proportional relationship. It is proportional. And then if we were to write the rule of what's happening, we know the rule would be y equals my constant of proportionality, whatever's being multiplied every time, times x. Here's my rule, with 65 being my constant of proportionality. Okay, so for means every hour that she drives x, we can multiply by 65 to figure out how far Lee has gone. Let's do one more problem, then we'll be done. So again, same idea. I have a situation here, and I want to tell if it's a proportional relationship, and then I want to give my constant of proportionality. So Sue types 45 words in 1 minute. So again, I'm going to use minutes, my unit of time, as my x, and then use the amount of words, my action, as my y. So 1 minute, 45 words. 2 minutes, 60 words. 3 minutes, 73 words. So I want to determine if this is a proportional relationship or not. And if so, what is my constant of proportionality? So after 1 minute, we're multiplying by 45 to get 45 words. Okay, so now what I need to do is I need to see 2 minutes. Am I also multiplying by 45? Does that mean is she reading at the exact same pace throughout this? Is her pace constant for how fast she is reading? How many words per minute she's reading? So if I take 2, if I multiply by 45, does it equal 60? So 45 times 2 is not 60, it's 90. So that means right now this isn't constant, because this is actually going to be times 30. And then 3 times something equals 73. I don't even know what it is. I'm not going to do it in my head right now because I'm not 100% positive. It's going to be some type of decimal. So this doesn't work either. So therefore, we don't have a consistent rule. We don't have a constant rule, which means we do not have a constant of proportionality, which means this particular situation is not a proportional relationship. Okay, and that's it. So what we're doing is we're taking situations, we're making input-output tables out of them, and then we're going to determine whether or not the relationship is a proportional relationship. Okay, and if so, we find that constant of proportionality, which is the rule that is consistent throughout. Hope this video helped. Please let me know if you guys have any questions. Thank you.